Welcome back to VTU e-Shikshana program on computer-aided engineering drawing. So far we have covered prisms and pyramids of different shapes, cone and cylinder also. Now we are taking cube. Already I have covered tetrahedron, it's a limiting case of triangular pyramid. Now this is particularly limiting case of square prism. Now I have square prism here. And this is having some dimension, say side equal to 80 mm and height equal to 150 mm. Suppose that if I limit the height to 80 mm only as side is 80, this is also 80. So this becomes cube. Okay, now I have a model of cube. This is 80 mm, say, then this is also 80 mm. It consists of 6 equal squares. That's why it is referred to hexahedron. Okay, tetrahedron, 4 equilateral triangles. Here it is 4 equal squares. So 1, 2, 3, 4. Then base and top face. Base and if you consider this particular item as base, then you can call it as base. Here all are faces, just like tetrahedron. Now we'll take up problems. The problems can be of prisms and pyramid type. Say the base is on the ground, or one face is on the ground, axis inclined some degree to HP and axis some degree to VP, or the one side on ground is inclined some degree to that, and all you know how to work out. That you can work easily. But there is a typical problem here I will take up now and discuss. Here we have a cube of 40 mm sides rests on HP such that a solid diagonal is perpendicular to VP and parallel to HP. What exactly the solid diagonal? So purposefully I kept this open. This just like sheet metal work I have done. Now I will catch one line, the very interesting line. Let me first define the corner names, then only it is easier for us to discuss. See, as usual, A, B, C, D, top face corners. Say, assume that this is top face for us, like prism, A, B, C, D. This is base of the prism, say. P, Q, R, S. I don't name A1, B1, C1 purposefully because I must be very clear about the solid diagonal. I have to define solid diagonal. How? Even otherwise I can define, but it's easy for me to have different naming. I name this as PQRS. P with A, Q with B, and R with C, and then S with D. Okay, A, B, C, D, PQRS in sequence. Now let me have this line joining R with A. R with A. That is one solid diagonal, or body diagonal. It's also called body diagonal. Otherwise, S with B. There is one body diagonal. Like that, you have 4 body diagonals. Okay, 4 body diagonals in this position. 4 body diagonals. I will take one and discuss. Which one you select? Whether nothing is given about whether it's edge condition or corner condition. You have to decide which condition you must take so that you get solid diagonal in this condition, perpendicular to VP, parallel to HP. That is, I will assume that this is solid diagonal of the cube, imaginary. You must get this type. See, this solid diagonal must be parallel to HP and perpendicular to. In this position, you must keep the cube. Okay, it's very interesting position. That is the basis for isometric projection. Okay, now I will keep this one of the solid diagonal perpendicular to VP and parallel to HP. Say, I will take 2 corners at random and see. Then we will see the corner names. I will keep this way. Okay, this is one corner and it's another corner that gives you solid diagonal. Okay, now if I take that particular name, this is P, this is C. That means you should select one corner of the top face and diagonally opposite base center. base corner. Then that gives you the solid diagonal. This particular solid diagonal if I select, then what I can do is, he also says it is rests on HP. You must keep the solid on HP also. Now I will keep this point. See, P is this, A is this, and then this is R. Okay, A and R. Now I will keep in this position. A, B, C, D, P, Q, R, S. Now I will make R on ground. I will keep R on ground and tilt so that the P and C becomes a line. Now P and becomes a line that is referred to as solid diagonal, and right now this particular solid diagonal is parallel to both the planes, HP as well as VP. See, this is the final position. This is the position. I will keep it like this and keep this line and see that this line is parallel to both HP and VP. Then you try to rotate. Assume that I have kept the P and C parallel to HP, then you rotate like this or rotate like this. Always we take base towards observer. Here you take top face towards observer so that the top face is towards you, so that you will get a solid figure. There also you get solid figure, but normally you take this reference to isometric projection so that you can see the top face is visible. Even you can do this way also. Both we will discuss. Now, I hope you understood what is solid diagonal, what position you have to take. First, let me name these points. While working, I will show the model and explain. P, Q, R, S are the base sides. It should be in bracket. Let me be very clear. A, B, C, D. Now, it should not be capitals because it is projection solids. Small letters. P, Q, R, S. A, B, C, D. Top view of the cube. Now this is as usual center, you need not worry. You can keep it at the end. Okay, this is, we are not using that as a reference at any moment. Just for the formality you have to complete. We will do it at the end to avoid any confusion. Next, project these points up. That means you have to take corner condition, not edge condition. If you take corner condition, then only you get the solid diagonal reference true length. I will show you how exactly you get the true length of the solid diagonal. Now, this is the height equal to side. Okay. Now, name these points. P dash, Q dash, R dash, in bracket S dash, then A dash, B dash, C dash, D dash. I am using colors just for explanation purpose. It's easy for me to interpret. That's why I am using colors for naming only. Otherwise, you must keep white and black always. Now, dark the visible points, visible lines. This is front view of the cube, which is placed with simple position. I can say the all sides are equally inclined to VP, or one of the side is parallel to, inclined at 45 degree to VP, or corner condition, simply corner condition for all even number of sides with one diagonal parallel to VP. Okay, that's all. Next, I have to keep this R on ground. Not necessarily, if this is not given, rests on HP is not given, I could have taken little up and I can keep it in space, no problem. I can keep this figure up do it. But you must have R corner condition only, it is above the HP, that's all. Now, how do you mark solid diagonal under consideration? If you keep R on ground, definitely P dash C dash will be your solid diagonal to be selected. Solid diagonal under consideration, P dash C dash. Actually PC. Actual solid diagonal is PC. The front view is P dash C dash, small P dash C dash. Now let me keep that with the green line. Okay, it should be a light line in your case also. Light line. Just for explanation purpose, I have kept green. Okay. Now, what you have to do first? P dash C dash must be made parallel to HP. So, initially, the solid diagonal is like this. Line joining corner P and C. Corner P and C. Now, I am making like this. First position, second position, third position. This is a problem on straight line, say. First position, second position, third position. That's what you have to do, but along with the cube. So, it's very interesting. And the many important information you get from this particular problem. See, this is the information for you. PC is under consideration, that is the solid diagonal, body diagonal. You have to make it parallel first. Okay, so I will show again the model. P, Q, R, S, A, B, C, D. I am keeping P as reference and C as reference. Line joining that gets you the solid diagonal. Then rotate such that P and C will be at same height. That means you make that line parallel. Imagine a line parallel, that is solid diagonal. Then tilt it. First position, second position, third position. In third position, the solid diagonal will be perpendicular to it. That's all. Next, how to redraw this? What reference you take? Previously, you used to take some angle and height, etc. Here, nothing is there. Now, the very important information I have, so it's fact. If you join this and this, in this position, standard position, if you join this corner, BD, front view, and this, you will always get 90 degree. You can check. Okay, this is characteristic feature of cube, particularly in this position. The sides are or lateral faces are equally inclined to VP or 45 degree to VP. Now, let me name this as M. Okay. Now, if I keep R dash M vertical, definitely P dash C dash will become parallel because they are mutually perpendicular to each other. That is what interesting thing. So, what I do is, I must keep R on ground, because it is rests on HP. I must keep something on HP. I am keeping this corner. Based on that only, I have selected PC as the solid diagonal under consideration for this purpose. Now, draw a vertical line. Yes. Now, you take this distance. Take this distance and mark here. Yes, this is M. Now, draw a horizontal line. This particular line is going to house two ends of the solid diagonal under consideration. See, P dash C dash is on a line perpendicular to R and B, whatever, at M. Yes, it's there. Now, you take this distance with compass and mark. Yes. Yes, this is P dash. That is P dash. Then next point is C dash. Again with compass you take. What I am telling is manually. In computer, it's very easy job. Move and rotate. How you rotate, you have to make this reference. There also you have to make this reference. You make this perpendicular, that's all. Automatically this gets you the PC parallel. Okay, next, how to complete? You finish rectangle out of this. See, you join R and this is another line. You make parallels to this line and this line, that's all. Geometry. Okay, now at the same time you see that this point, projected point, the vertical line should catch this, otherwise it is wrong. Okay, now draw perpendicular again, or arc method you do. Take this as center, take total length, front view length, top length, take draw arc, then do it. Okay, now I hope I am matching with the pattern I have. Okay, yes, it's matching. Now take this as radius and draw arc. Again with this as radius, height equal to radius, draw arc, that is side. Now automatically this point becomes the center of the top line, that's all. See, this becomes B dash and D dash. Then complete this midline. See, this is how you get the front view in second figure. Now name this, as I already told, better I take this no. Okay, now I take this, draw this one. Now A dash, B dash, C dash, D dash, then PQRS, P dash, Q dash, R dash, S dash. See, I told you if you draw perpendicular, it will catch this or join this. Here also it's very interesting. This lines, whatever you draw from all corners, baseline and this. Again you draw this one, you will get single line. You draw join this and this, you must get single line. If you get more line, more marks. That means this is wrong. Now see that the projections are very clear and you must do it neatly. And in case of computers, no problem because you are redrawing same thing, but you should see that this is perpendicular. You get only 4 lines, 4 projections. Then draw. Yes. Now this is P, this one is Q, this is R, this is S. Base center. Join that. Join them with light lines. Next, same point will be your yeah, this one is actually A, yeah, A, this one is B, this is C, this one is D. Join them. Let me use different color so that you can understand. This is A, B, C, D. Now keep the boundary dark, little bit. Now assume that all are light lines. You have A, B, C, D, PQRS. That's why I have selected 2 different naming type. That is PQRS, A, B, C, D, not AA1, BB1. Now you are here, observer position. The top face ABCD is nearer to the observer, so top face ABCD is visible. Okay. So join all lines with dark lines. So ABCD visible edges and this is visible. Dark lines. Next, border lines completely dark. Or you can also utilize the farthest item from you. See, farthest item from you is R. R is not visible. Any number of lines connecting to that are not visible. See, RC, RQ, RS are not visible. Yeah, that we can do. See, it is not visible and rest of the lines are visible. That's all. Only these 3 are not visible, rest of the lines are visible. That is this also visible. All boundary lines except R. You can also have this key surface method. Top surface is visible, boundary lines visible. Invisible key surface is PQRS. Out of PQRS, PS and PQ are visible because it is boundary. These two are dotted. Then invisible bends, visible bends. That's all. Otherwise, in this case, you can always use farthest item from you, that is R. These three are not visible. Rest of the lines are visible. That's all about the second figure top view. Next, what about the next item? Like PC right now is parallel to both the planes. First position of PC, second position of PC. Now, yeah, third position of PC. Okay. First position of PC, here, first position, second position, now third position. That's what required for you. Now, how to redraw this? Again, you have to redraw that such that you get final front view. So, which one you want? Normally, I take base towards observer. Now, I will take top face towards observer. You can also try base towards observer. Okay. Now, let me draw a line. It's again very easy to draw because number of lines are less here. Mark two extreme points here, P and C. So you are taking base towards observer means P towards observer, C towards the, P towards VP and C towards observer. Now let me mark these points in one go. This is P, this is A, this one is R, next comes R to C, X. So I can mark as per the this one, yes, this is A, this one is R, this is C. Draw perpendiculars through R and A. Only one distance you have to take, complete the figure. What the distance? R to B or A to Q, A to S, R to D, all are same. Mark this. Yes, same distance. Yes, join this as in the first figure, second figure top view. Boundary lines dot, top face dark ABCD, sorry, let me name better, before that let me name. Okay, A, if you take C this side, B, this is B, this one is D, this is A, B, C, D. Now P, Q, R, S. Okay. Now I am marking A, B, C, D, visible. That's what we have taken here. Yes. P, Q, R is not visible, but boundary lines are covered by the P, Q, two lines. Next, visible bends, invisible bends. You can always utilize that reference. Okay. Now this is final top view. I am no way connected with axis now because if you take that it leads to confusion. Don't write. At the end if you want you can write. Okay. Otherwise limit to this only. Now take this up to get the final front view. It's a very interesting figure. It looks like diamond. Take all points. Now, please see that PC is a single line and horizontal line is a single line. Don't get confused. Single line, because if you make two lines, problem starts. Because it is horizontal line, you know very well. Then top face, projectors, base projectors. That's all. Now keep this points. This is topmost point is A dash, A dash, this is B dash, this one is D dash, this is C dash. Similarly, this is P in bracket because it is away from the observer, C is visible, not P. This happens to be a solid diagonal also. This is Q. R is on ground, definitely, this is on ground. This one is yes. Okay. Now, join these two with light lines first. See, as again I told you, it has got characteristic feature of this particular problem and unique procedure. You have to continue this line so that it will catch this point. So even if you do independently, you see that these two are lines like this. Okay. Now complete the boundary. Now you are here. I am having ABCD. Don't do this, but the explanation purpose only I am doing this. ABCD is visible. Even on computer I can show you by shading. ABCD is towards you. That is nearer to the, even looks, you can see it in top view as well as it is nearer to you, it is visible in front view. Now what to do? Dark this front view ABCD. Okay, this is the visible surface. Then boundary lines dark. Invisible surface other than boundary lines dotted. This is key surface method. Otherwise, P is the remotest point, that is farthest point. P is not visible. There is confusion. C and P are coinciding. That's why you get confusion. So what you do is you do with keep surface method, or if you are comfortable, you can do with P only. So P, Q, PS and PA are not visible because remote farthest point and whatever the lines joining that are not visible. Rest of the lines are visible. What about CR? CR is definitely visible because invisible surface, visible line, or bends, visible bends. This one is invisible bend because backside is there. PA, PQ, PS are invisible bends. So you can see this vertical figure looks like diamond, a particular type of diamond shape. So this is a unique problem, this limiting case of square prism. This normally appears in exams. Okay, so you can work this same problem as corner condition and axis inclined at some degree to HP and some degree to VP. So other than PC, they may give axis reference or the edge which is passing through the side which is passing through the corner on HP is inclined at some degree to HP and axis inclined at some degree. Any type they may give. You know all those right now. This is a unique problem. So this actually completes the projection of solid. There are many other important problems you can go through and then try to solve with the knowledge whatever you got from the worked out problems so far. Okay, now let us take the hexahedron or cube problem with 40 mm sides which rests on HP. Says that a solid diagonal is perpendicular to VP and parallel to HP. Dot projections. Now the corner condition is must for this problem because if you take corner condition, then you will get the solid diagonal. One of the solid diagonal parallel to VP says that you get the true length of solid diagonal. So anytime say solid diagonal is top corner joining diagonally opposite base corner becomes a solid diagonal. In this case, I have selected PC as one of the solid diagonal or AR. That is the only two possibilities. So if we want to go forward direction for inclination purpose to make this parallel and perpendicular to VP, I must keep R as the corner on ground. So if I want to keep corner on the ground as R and want to keep PC parallel to HP initially, then I must see that some reference is there to make this parallel. I cannot simply take. So I must measure this distance first. I have to draw perpendicular distance and measure this distance and then draw a line. Instead of that, what I can do is, its characteristic feature of this particular solid, and in this position, if you join R with BD front view figure, you will get definitely perpendicular line to PC, that is solid diagonal. So you can take this as a reference and make this perpendicular. Definitely this figure, whatever you redraw with this reference perpendicular, this becomes parallel because these two are mutually perpendicular. So with this background, what I do is I will move this and rotate this solid, front view, such that R dash M becomes vertical, that is perpendicular to HP. So I have written redraw first figure and front view such that MR is perpendicular to XY, MR dash is perpendicular to XY. Then PC becomes parallel to XY. PC is the solid diagonal parallel to both the planes now. in this position. So what exactly you have to do is, now I will take this and show you how to do it. So I hope you know how to draw the corner condition of the square and then project it height equal to height of the solid. Now check the validity. See, this is 40, height is also 40. Okay, so this is how you can complete. Now I will show you how to now redraw this figure. Okay, now I will select this move command first. Move command, and with reference to this I will take this. See that this is dark. Now I will keep it here. Yes. Now make this perpendicular. Automatically P dash C dash becomes parallel line. In that case, the situation is PC parallel to both the planes. Okay. Now rotate. In case of manual thing, you know, you must use arc method and complete. It is also easy, but in computer it is easier. See, keep this vertical. You have definitely the good reference previous line. You know that line is vertical, and also you see that this is blank. Okay, vertical. That vertical symbol is coming. Now see, PC is parallel to both the planes. This is how you can work the problem. Now that's what I have given here. Okay, so you see that this is 90 degree, definitely. Now you project it and get the top view. Okay, so as I told you earlier, you will get 4 lines only. 1, 2. Similar to this, we have A dash coinciding with Q dash, S dash, one more line, and P one more line. Okay, so then draw the top view with light lines, and then see that the top face is visible. Then boundary is completely dark, and then invisible lines, surface, edges other than boundary lines dotted. Then bends. Otherwise, farthest item is R, that is best. R is not visible. Any number of lines connecting to that are not visible because all 3 lines are well within the boundary, not on the boundary or somewhere in confusing state. So you can use this farthest item method. Farthest item from the observer is R. R is not visible. Definitely RC, RQ and RS are not visible. Rest of the lines are visible. That's all. Now what you do is you move this to this place such that this PC is perpendicular to VP. Whatever you do here, that is for VP. Okay. Now the next thing is this. We have moved and then projected. I made this ABCD visible because it is towards observer. Definitely it is visible. Then boundary lines dark. The invisible surface PQRS because it is away from the observer, and there are 4 base edges. Out of 4, 2 are already covered by the boundary line, and these 2 are again dotted. Otherwise, farthest item from you is what? They think there is small ABCD. This is okay. Very small problem here. This is PQRS. This is PQRS. This is Q. Yeah, Q. See, in the other direction, it looks like this. Better you change to vertical position. Q looks like B, in fact. Okay, that's why I got confused. Now PQRS is not visible, so definitely this is dotted other than these 2. All lines are dark other than these 3. Okay, so otherwise the RC is visible because of bends, and again PQ and PS are dotted. These are also dotted. Visible surface, invisible line, invisible surface, visible line. So that's how I just took this opportunity to shade and show you just for explanation purpose only. This one is visible surface in top view. See, you can see red line, dotted line, visible surface, invisible line. Here also same thing. Visible surface is this top face, and lines passing through that is only one line, that is AP, that is also not visible. So visible surface, invisible line. Here invisible surface, visible line. Okay, fine. So this is about the cube. I already worked out typical problems on tetrahedron and all other prisms and pyramids, along with cone and cylinder. So this is what about the model 2 projections of solids. So any problem you face, you try to go through the previous items, or particularly concept, basic concept, try to know and complete. Okay, and see that in the next modules we will work out development of surfaces and isometric projections.